And all the rest of this is parallel lines. It's profound, but very simple. So from here to here, he had this line. So all he did was he drew parallel lines from the 9 to the 3, from the 8 to the 4, from the 7 to the 5, and then you stop on the 6. It just ends there. All right? And then he had this line from the 1 to the 5, so he drew parallels from the 8 to the 7, from the 9 to the 6, from the 1 to the 5, and from the 2 to the 4, and then you end on 3. And when he finished doing that, these parallel lines, he had this symbol. And he became very interested in it. He thought there was something interesting about it, and decided that he wanted to explore it further. So it's a wild and crazy beginning to a story that really only gets crazier. I mean, most people, if you started with an intro like that, they would just think, all right, you know, here's another, I don't know, New Age maniac, or maybe an Old Age maniac. But, and I might be inclined to agree with them half the time, but the truth is that the further and further we've taken this, we're actually seeing the results now. It's quantifiable, it's measurable. And so what this became, what this has always been, is it's a model for harmonics, for sound, for space, and for how it's being created. And all the scriptures, you know, they always talk about, in the beginning was the Word. You know, in the beginning, and God says, let there be light, or in the beginning was the Word. Because sound is the fundamental power behind everything. In fact, I would go as far as to say that under certain conditions, sound will transcend the speed of light. And most physicists would look at you like you were insane if you say something like that. But actually, science pretty well bears it out. Everybody knows that conventionally it's said the fastest thing traveling in the universe is light through the vacuum of space. Light slows down when it comes into a heavier medium, so when it comes into the atmosphere, it's moving a little bit more slowly. The heavier and denser the medium, the slower it will move. Sound is the opposite. The denser the medium of sound, if you project sound through the earth, it's going to travel faster than in the atmosphere. Because it's solid and the atoms are closer together and they vibrate more quickly. Well, when you get to a black hole, which is ultimately what this right here is modeling, took, again, many, many, many years to figure that out. But ultimately, that's what this is, the reprocessing center of a black hole. At the center of a black hole, I've heard it said, I don't have confirmation on this, and I'm sure no one knows, but they say 100 million suns is condensed down to the size of a pinhead. 100 million suns, you know, that's a huge, I mean, that's crazy how, you know, I can't even imagine that, how dense and how bright that must be. And so when the matter gets that dense, it gets so dense at a certain point, which is what a black hole is, that the light can't escape it. Because the escape velocity of the matter is actually, the light doesn't have the velocity to escape the matter at that point, so it becomes trapped, and hence they call it a black hole. But the truth is that it's been proven now, and in fact NPR did a piece on this, that the black holes are emitting sound. And I think they measured the one from the center of our galaxy at roughly a B flat. And they are producing also coherent radiation. And so what that means to me is that at the core of a black hole, when the light can't even escape it, sound is penetrating that matter. Okay? At extreme velocity, in quantum mechanics they call it hypersound. It's when sound becomes so fast, such a high frequency, it's not even a wave anymore. They say it becomes like a particle, or a quasi-particle, meaning that it doesn't have mass. But at the core of that hole, the sound actually transcends the speed of light. That's what I believe. And that is where you get pure, fundamental, you can call it energy. It's like E, and E equals mc squared. I mean, E is just energy. It's kind of undefined. We called it by the term etherons, which they used to propose in ether, that there was an energy diffused throughout space. I don't know if you guys remember, anybody here remembers, and they used to have the radio programs, and they'd say, coming to you over the ether waves. You know, so they used to think there was this medium with stuff traveling through it until what's called the Michelson-Morley experiment, where they measured the drag of the Earth through space, and they said there was no resistance, so they didn't need to postulate an ether. And so it was thought after that there is no ether. But the problem was they were looking at it like a static, stationary ether, like what they called a loquacious jello. But the truth is, it's not a loquacious jello, that it is actually a pulse. It's an energy. It's coming from the inside out. Okay? That's one of the fundamental principles of math that's neglected these days, that all calculations and all math comes from the inside out. It's just how reality works. So like whether it's a rose growing, whether it's your own body being grown, it is a doubling process that works from the inside out. And that's how the growth works. So even energy, math, everything is working like that. And so I know I'm jumping to a lot of different topics. That's always my problem. But let me go back to the symbol now and just tell you a little bit more about what this is modeling. And I'm going to get in here and show you some more images so it can be a little more clear. But like I mentioned in the TED Talk, essentially what we found that we had here was two different systems. One is this pathway, this circuit here, which you can see is it's a closed loop. And this other one's this triangle here. And they seem to be operating in totally different worlds. You could take a lot of explanation. I'll try to just be short with it. But eventually what we came to is realizing that this circuit, which let me just show you something about these numbers, for instance. If I take 1 and I follow this to 2, it's doubling, right? 1 doubled is 2. 2 doubled is 4. 4 doubled is 8, right? Pretty clear so far. 8 doubled, though, is 16, but here we have a 7. Well, why do we have a 7? Well, if you add the numbers together, which is called decimal parity, or sometimes it's called digital roots in computers, or numerology, you get a single digit. 6 and 1 is 7. Now, just to ask the question that should be asked, why would you want to add the numbers together, and what's the point of that? And the point is that you're finding an underlying pattern, that underlying all our big numbers and all our sequences, that there's a pattern under it. There's this essential geometry or structure. I don't know, there we go. And so 8 doubled is 16, 6 and 1 is 7. 16 doubled is 32. 3 plus 2 is 5. Right? 32 doubled is 64. 6 and 4 is 10, and 1 and 0 is 1. Right? I'm not going to make you go through all this, but I'll just tell you, 128 equals 2, 256, 4, 5, 12, 8, so on and so forth. 1024 is 7, 2048. You can go on and on forever doubling, and you will never break this pattern. 1, 2, 4, 8, 7, 5. It is a pattern that underlies, as I said in the talk, the growth of your cells in your body, which is a doubling process. And you can see if you have 1 cell, and then doubles to 2, and then 4, and so on and so forth. So that's one example. Computers, the binary code is an example of doubling, so we use it in computers all the time. Nuclear reactions are based on doubling. The musical scales from C to C to C is a doubling process. That's just how harmonics works. It's just a mathematical principle. And what we discovered is that doubling is a circuit. It's a pathway of motion. It's not just a linear sequence. That it actually is modeling a geometry, a curvature, a train track, if you will. So no matter how far you go up in your numbers, that doubling pattern will always be there. And people have taken it really far at this point, believe me. And it never breaks, and it never will. But it's a little bit better than that, because what I'm really modeling here, and everything that I'm going to show you, why this touches spiritual, why it touches physics, why it touches philosophy and logic, is because what we're claiming here is that we have mathematical perfection. Okay? That means nothing, no redundancy, nothing omitted. If there's ever one mistake ever found in this math, and it's been said from the beginning, we throw the whole thing away. it's garbage. One mistake. And so far, you know, we've been all around, and no one's ever found one. So if you go in the opposite way, though, just to show you, it's a little more than that. We get something interesting. Going the opposite way, you can do halving. Okay? So let's take a look at it. Half of 1 is 0.5, right? Half of 0.5 is 0.25. 2 plus 5 is 7. Half of 0.25 is 0.125, which equals 8. Half of that is 0.0625, which equals 4. Alright? Same thing. You can halve forever, and you will never break that pattern. I was pretty impressed by that when I first saw it, because I never expected that that kind of a pattern was there. But okay, so that's a start. There's a coherence there. There's a pattern there. So that was kind of interesting. Well, let me show you something else, because this is where you really. Excuse me. Well, you're all awake now if you weren't a minute ago. Alright. So I said what we were modeling is mathematical perfection. It's a blueprint for creation. And so, and again, that wasn't a name that we assigned to it. That was actually a statement that was made by a gentleman from Microsoft who said that, who was a mathematical genius who revolutionized computers himself. And he said that if anyone had told him that somebody had done something like this a few months before he saw it, that he would have said it was impossible. And I got that same statement from a gentleman who was one of the top guys at LinkedIn that I met in San Francisco last year. And when we told him what we were doing mathematically, he said that's impossible. And we were at a ping pong table, and they pushed everybody away, and they got this big roll of paper, and they rolled it out on the ping pong table, and we proceeded to do it right there on the table. And he said he was so amazed by what he saw. And what he saw was basically a dimensionalized representation of this right here. So what do we mean by perfection? Well, let's just take a look. If we do, I'm not going to take you past anything, and I said in the talk, what we did was we unified the functions of math, which is addition, subtraction, multiplication, and division. That's it. That's all you can do. And then people get crazy. What do you mean that's all you can do? What about sine and cosine? What about all these other things? It's all just a part of this function, because what we're doing is we're doing it all at once. So instead of saying like conventional science, or like conventional science would have us believe, for the most part, that at least the perspective I see on TV and hear from most of professors in the university, not all, is that creation is at best random. You know, to me, I don't even know what random means. Does anyone even know what random means? Has there ever been any evidence of anything random? I mean, completely random. I don't know. You have?
Random row books.
Random row books. That's right. We're in random row books. All right. Well, you got me. You just got me. I'm down on the stage.
It's not really random.
It's not really random, right? We all had a purpose in me.
There's some order to this.
My friend John and I just met again recently. We just found out today we were standing on the same street corner like 10 years ago. And we were probably standing right next to each other and didn't even notice. So, thanks for the water, by the way. So, what we're doing is we're creating this model of perfection. So let me just show you how every calculation you could do, whether it's addition, subtraction, multiplication, or division, can be done in one simple model instantly at one time. Alright? So here we go. We're going to do it quick, so you guys just hang with me, and if you don't get it, you can watch the video. But I think you'll get it.